Hello everyone, welcome back to another experiment in Introphysics Lab, and today we'll talk about free fall. Just imagine for a moment an object, let's say a basketball, and you're dropping from a certain height. I'm using a picture here where the ball is captured in different positions, and this is called motion map. As you see, the ball is accelerating as it moves down. Think for a moment about the forces applied to the ball. The first that comes to our mind is the force of gravity, the force applied from the Earth to the object. And this force of gravity is directed downward. This is how we use it most of the time in the problems. We consider only the force of gravity, and that's why we call this motion a free fall motion. But in reality, it's not only the force of gravity applied to the object. Can you find another force? The object moves through the air or any liquid. Does the air or any fluid, liquid, fluid, air apply a force? And everybody will say, yes, it does. And we call that the air resistance, fluid resistance, or the drag force. What is the direction of the drag force? Think about that. And at this moment, I would like you to pause the video and draw the free body diagram. Represent any kind of object that comes to your mind with a particle model. We use a particle model to represent the object, and draw the forces. Do you have two forces? What are the directions? And the most important to think about is what is the size of these two forces, the size of the vector that you are using to draw the forces. I hope that at a beginning, when the object is held at a certain height, you have drawn only the force of gravity because the object is not moving. As the object moves downward, the speed increases, and this speed affects the drag force, which means that the drag force is increasing. On the other side, the object is accelerating downward, which means in terms of forces, the force downward is greater than the force upward, so the net force is downward. But since the drag force is increasing, there will be a moment when those two forces, the force of gravity and the drag force, are the same. So they balance each other, which means that the net force is zero. And at this moment, the object will continue moving at constant motion. During the constant motion, the velocity is constant. And that is the terminal velocity. So for our experiment, we want to see what are some characteristics of the object that affects the terminal velocity. For the purpose of this experiment, I'm going to use the styrofoam ball. I can drop the styrofoam ball like this, or like this, or like this. I can have this styrofoam ball, or I can have a bigger one, which means that I'm changing the mass. At this question, we are going to concentrate our attention only on the change of mass. How do different masses affect the terminal velocity? In order to change the mass of the styrofoam ball, I want to keep the cross-sectional area the same. Because if I change both of them, I don't know the effect of each of them on terminal velocity. So I'm changing only one factor, only mass. And for this reason, I'll stack different balls. So starting with 1, 2, up to 6 balls. measure the mass of one ball. And that tells me 2.2 grams. And we'll drop this ball from a height and record the motion using motion sensor. The motion sensor is put on the floor and set into the ball setting to collect the data and to show the graph with the better resolution. So I'll put this on the floor, and with help of my friend Nathan, use LoggerPro to collect the data and to analyze the graph to see how the motion, the mass of the ball will affect the terminal velocity. All right, Nathan, we are ready. Go. Okay. So in this graph, you have the position versus time graph and the velocity versus time graph. You can use either of them. I will zoom in and see how the graph changes. Based on the discussion that we did at the beginning, I would like you to find out from what moment to what moment the object is accelerating, and from what moment to what moment the object is going through constant motion. And then based on that, come up with the idea of how to find the terminal velocity. We are going to perform the experiment with different amount of balls, and we'll provide you all the trials, the graphs, for each number of balls, which means for each mass. You can use the position versus time graph, or you can use the velocity versus time graph. Either of them will give you the same result. After you record the terminal velocity for each ball, for each mass, you plot a different set of data, mass and terminal velocity. So the other graph will be terminal velocity versus mass. And then it will give us the relationship between those two quantities, and it will tell us how the mass affects the terminal velocity. Thank you.